Hello everyone, welcome back to your own chemistry channel, and today I am going to discuss the different methods of calculation of bond energy, and I will explain these methods with the help of a numerical problem. So the numerical is calculate the bond energy of HCl given that the bond energies of hydrogen and chlorine are 430 kJ per mole and 242 kJ per mole respectively, and the enthalpy of formation of HCl is equal to minus 91 kJ per mole. Okay, so let us discuss the first method, and first of all we will calculate the bond energy of HCl using this relationship, that delta H of a reaction is equal to the sum of the enthalpies of formation of products minus the sum of the enthalpies of formation of reactants. Okay, and here we are given with the bond energies of hydrogen and chlorine, and we know that the bond energy of hydrogen is the amount of energy required to dissociate 1 mole of hydrogen molecules into 2 moles of hydrogen atom, and energy absorbed during this reaction, that is delta H of the reaction, will be equal to the bond energy of the hydrogen. Okay, so therefore the delta H of this reaction will be equal to the bond energy of hydrogen, and which is given 430 kJ per mole. Likewise, this equation gives us the dissociation of 1 mole of chlorine molecules into 2 moles of the chlorine atoms, and the energy absorbed during this reaction, that is delta H, will be equal to the bond energy of the chlorine molecules, and here it is given plus 242 kJ per mole. Understood? So this is the equation number 1, and this is the equation number 2. And here we want to calculate the bond energy of HCl, and the bond energy of HCl will be the energy required to dissociate 1 mole of HCl into 1 mole of hydrogen atom and 1 mole of chlorine atom, and the heat absorbed, energy absorbed during this reaction will be the bond energy of HCl, that is delta H of this reaction will be the bond energy of HCl. So we will calculate the delta H of this reaction, and let this is equation number 3. Okay, and we will calculate the bond energy using this relationship, that is delta H of the reaction is equal to the sum of the enthalpies of formation of products minus the sum of the enthalpies of formation of reactants. So here reactant is HCl, okay, and products are hydrogen and chlorine atoms. Okay, so the delta H of this reaction will be equal to the enthalpy of formation of 1 mole of hydrogen atoms plus enthalpy of formation of 1 mole of chlorine atoms minus the enthalpy of formation of HCl. Understood? And we can easily calculate the enthalpies of formation of 1 mole of hydrogen atom and 1 mole of chlorine atoms with the help of these equations, equation number 1 and 2, because in equation number 1 hydrogen atoms are being formed, and in equation number 2 the chlorine atoms are being formed. But we know that the enthalpies of formation is for the formation of 1 mole. Okay, but here 2 moles of hydrogen atoms are being formed, and here 2 moles of chlorine atoms are being formed. So the enthalpy of formation of 1 mole of hydrogen atom will be equal to the half of delta H of this reaction, that is half into 430 kJ per mole. Likewise, the enthalpy of formation of 1 mole of chlorine atoms will be equal to half of this value. So the enthalpy of formation of 1 mole of the hydrogen atoms is equal to half into 430, which is equal to 215 kJ per mole, and enthalpy of formation of 1 mole of chlorine atoms will be equal to half into 242 and 121 kJ per mole. Okay, and here we are given with the enthalpy of formation of HCl, which is equal to minus 91 kJ per mole, and we will substitute all these values in the equation number 4, and we will have delta H of this reaction will be equal to 215, enthalpy of formation of 1 mole of hydrogen atoms, plus 121, enthalpy of formation of 1 mole of chlorine atom, minus into minus 91 kJ per mole, where minus 91 kilojoule per mole is the enthalpy of formation of HCl, and after solving it we will have 427 kilojoule per mole, and 427 kilojoule per mole is the enthalpy, delta H of this reaction, and I have explained it that delta H of this reaction will be the bond energy of HCl. Okay, so in this way we have calculated the bond energy of HCl using this relationship. Now let us discuss the second method. And in second method, let us write here the second method. And in second method we will calculate the bond energy of HCl by using the relationship, that is delta H of the reaction is equal to the sum of the bond energies of reactants minus sum of the bond energies of products. Okay, and I will explain this relationship in my next video when I will discuss the calculation of enthalpy change of a reaction using bond energy data. So I will use this relationship now for the calculation of bond energy of HCl. Okay, and the chemical equation for the formation of 1 mole of HCl is, that is, half mole of hydrogen molecules plus half mole of chlorine molecules giving us 1 mole of HCl gaseous. Okay, so this equation represents the formation of 1 mole of HCl. Understood? And I have told you the enthalpy of formation of a compound is the energy absorbed or evolved when 1 mole of a compound is formed from its elements. Okay, so the delta H of this reaction will be equal to the enthalpy of formation of HCl. Understood? So the delta H of this reaction will be equal to the enthalpy of formation of HCl, and here we are given this value, it is minus 91 kilojoule per mole. Okay, and according to this relationship, the delta H of this reaction will be equal to the sum of the bond energies of reactants, that is half into bond energy of hydrogen plus half into bond energy of chlorine minus bond energy of products, that is bond energy of HCl. Okay, and delta H of this reaction is given, it is equal to minus 91 kilojoule per mole, and it is equal to half into bond energy of hydrogen molecules is 430 kilojoule per mole plus half into bond energy of chlorine molecules equal to 242 kilojoule minus bond energy of HCl. Okay, and let us solve it further. Minus 91 is equal to 215 plus 121 minus bond energy of HCl, and let us rearrange this equation. Then bond energy of HCl will be equal to 215 plus 121 plus 91. Okay, and it will be equal to 427 kilojoule per mole. Understood? So in this way we can also calculate the bond energy of HCl with the help of this relationship. Now let us discuss the third method. And in third method we will calculate the bond energy of HCl using Hess law. By using Hess law. By using Hess law. Okay, so here we are given that bond energy of hydrogen molecules, that is 1 mole of hydrogen molecules is dissociated into 2 moles of hydrogen atoms, and delta H of this reaction is equal to plus 430 kilojoule per mole. And equation number 2, that is dissociation of 1 mole of chlorine molecules into 2 moles of chlorine atoms, and delta H of this reaction is equal to plus 242 kilojoule per mole. Okay, and I will also write here equation number 3, which will be for the formation of 1 mole of HCl, as I explained in the previous method, that is half H2 gaseous plus half Cl2 gaseous, giving us HCl, 1 mole of HCl, that is HCl gaseous. And I explained that delta H of this reaction will be equal to the enthalpy of formation of HCl, and it is equal to minus 91 kilojoule per mole. Okay, and we aim at that our desired equation is, we aim at HCl gaseous, 1 mole of HCl gaseous giving us 1 mole of hydrogen atoms and 1 mole of chlorine atoms, and as I said that delta H of this reaction will be the bond energy of HCl. Okay, now what we will do, we will arrive at this equation, okay, with the help of these 3 equations. And to do this we will multiply the equation number 1 by half, equation number 2 by half, okay, and then we will add these equations, and after adding we will subtract the equation number 3 from it. So let us multiply equation number 1 and 2 by half. Let the resulting equation is equation number 4. So after multiplication I will have, that is half H2 gaseous equal to 1 mole of hydrogen, 1 mole of hydrogen atoms, and as I have explained we will have to multiply the delta H of this reaction also by half. Then we will be having delta H equal to 215 kilojoule per mole, and this is equation number 4. And now I will multiply the equation number 2 by half, and let this is equation number 5. Half Cl2 gaseous, half mole of Cl2 gaseous giving us 1 mole of chlorine atoms, and delta H of this reaction will be equal to 121 kilojoule per mole. Okay, here again I have multiplied the delta H by half. Now let us add equation number 4 and 5, and after addition we will have half H2 gaseous plus half mole of Cl2 gaseous, giving us 1 mole of hydrogen atom in the gaseous state and 1 mole of chlorine atoms in the gaseous state, and the delta H will again be added and it will be equal to 336 kilojoule per mole, and this is equation number 6. Okay, now what I will do, I will subtract equation number 3 from the equation number 6. So let us write this equation number 6 again, that is half H2 gaseous plus half Cl2 gaseous, that is half moles of each, giving us 1 mole of hydrogen atoms gaseous and 1 mole of chlorine atom gaseous, and delta H is equal to 3 plus 336 kilojoule per mole. Okay, so this is, I have written this equation again, that is equation number 6, and the equation number 3 was half mole of H2 gaseous plus half mole of Cl2 gaseous, giving us 1 mole of HCl gaseous, and delta H of this reaction was equal to minus 91 kilojoule per mole. Okay, and as I said earlier, now I will subtract the equation number 3 from the equation number 6. Okay, and I have told you that for the subtraction we have to change the signs of the reactants, products, and the delta H of this equation number 3. So here minus, it will become minus, minus here, and the sign of delta H will become plus. Okay, and here 1 H2, these cancel each other. So what we are left? We are left with 0 on the reactant side, and we have 1 mole of hydrogen atoms plus 1 mole of chlorine atoms minus 1 mole of hydrochloric acid in the right hand side, and now the enthalpy change, the delta H will be added because both have the same sign, and after the addition we will have delta H equal to 427 kilojoule per mole. Understood? Then let us rearrange this equation again. We will bring this HCl towards the left hand side, that is towards the reactant side. We will have HCl gaseous, giving us H gaseous, 1 mole of H gaseous plus 1 mole of chlorine atoms gaseous, and delta H is equal to 427 kilojoule per mole. And now we have arrived at our desired equation, and I have explained it that the delta H of this reaction will be the bond energy of HCl. Understood? So these were the different methods which are used for the calculation of bond energy, and in my next video I will discuss that how do we calculate the heat of a reaction, that is delta H of a reaction, with the help of the bond energy data. So keep watching my videos, like and share my videos, and subscribe my channel. Thank you very much.